Well, to get us started a little bit now as we go on to page 26. Page 26. What is an expression? What is a term? And what is the degree of a term, and then later the degree of the expression? Some background. Well, an expression is a series of terms. And a term is separated by either a plus or a minus sign. So for instance, how many terms do we have here? Well, 1, 2, 3, 4. Now, within a term, let's say this one, 4x to the 5th, we see we have a variable, and we have an exponent to which that variable is raised. So this means, in a sense, there are 5 x's there. And we also have a number in front of the variable. Now, if there is no number there, then we put a 1. We assume a 1 is there. A 1 is in front of everything. Now, when we think of the degree of a term, we look at the variables only, and we add up all the exponents on the variables. Here there's only the 1. Sometimes we'll have 2 or 3 letters with exponents. We would add up those exponents on that single term. So the degree of this polynomial, the first term is 5. The second term is 2. This one is, since there isn't any variable, it's 0. And the exponent on this one is 6. So when you want the degree not of a term, but of the polynomial, and this is where it can be a challenge if you don't get it correct, it's what is the highest of any single term, the degree of any single term. And the highest one is 6. So the degree of this polynomial is 6. And as we look at example 2, it's probably a good idea to list them. This is, degree of this is 5. This one is 3. This one's 7. This one's 2, and this one is 0. So the highest degree is 7. What is the degree of the polynomial? Now, in example 3, they want you to list the degree of the following polynomial, list its coefficients, and its constant term. So as we look at this, the degree of this one is 3, degree of this one is 2, this one is 1. If there's no exponent, remember there's a 1 there, and this is 0. So the degree of this polynomial is the largest of any single term. It's 3. Now the coefficient is the numerical part of each term, which in this case is a 9, here a positive 3, a negative 4, and this one, in a sense, it doesn't have a variable, so we consider this one the constant term, and this is 8. So once you know the vocabulary, it's a little easier to follow. So the degree of this is 1. The degree of this is 2. Degree of this is 0. Degree of this is 3. So the degree of this polynomial is 3, the highest of any individual term. Now the coefficients, here it would be 8.5, 5.6, a negative 3.2. Now this one doesn't look like it has one, but remember we said there's always a 1 there. And the constant term in this case, is the negative 3.2, since it doesn't have a variable. Now, sometimes, just to give you some background on this, we might think that is x to the 0 power. If you recall, we said anything to the 0 power is 1. So that's why the degree of this is to the 0 power. This x to the 0 power is 1, so it doesn't change this value at all. All right, doing the same thing here. This is 7, 1, 0. So the degree is 7. And then these are the coefficients. That is the numerical part. And if it doesn't have a sign, of course it's positive. When it does have the negative sign, we have to include that. And then this would be the constant. All right, that was a real short one. Now in our lesson, of course, we will go over the rules involved here. And in your textbook, there is a chart that summarizes it. So for something like this, when we have a base, and the bases are the same, we just add the exponents. So this is going to be 8 to the 15th power. Now here we have an interesting thing, because we have something in a bracket and then something in a parenthesis, and then outside the bracket we're raising that. So in a sense, this base here would be written 3 times. So in this case, instead of adding exponents, we're going to multiply, and we get this. 6n. Now 2 times 3 is to the 6th power. Now, to actually do this, though, we're going to go 6, and there's a 1 there in a sense, so that's 6 to the 6th power, and there's a 1 by the n, and we're going to multiply that. That is n to the 6th power. Checking the answers on page 51, we see that they leave it in this form. Normally you would go 6 caret 6 on your calculator and get a value for this. That would really be simplifying it, but that's as far as they're going here. Now for example 3, again our bases are the same, so we can go 2m to the 5th power. And then simplifying that, that would be 2 to the 5th, m to the 5th. Now 2 to the 5th is 32, m to the 5th, but this is how they're showing the answer on the answer page. Again, our base is the same, so this is going to be a negative 4 to the 8th power. Now, when you simplify this some more, since you are raising a negative value to an even exponent, the answer is going to be positive. But they're not asking us to do any more there. Okay, so that was a short lesson. Now, in this next page, page 28, we're asked to add or subtract as indicated the preceding polynomial. So I'm going to suggest a way to do this, and I'll set it up for you. And the strategy for these, I believe, is to put your terms in like term columns. So x to the 3rd is under x to the 3rd, and so on and so forth. So now it's just a matter of adding your numerical coefficients, and you get 11 x to the 3rd. Now when you're adding a negative 7 and a 9, you're actually subtracting. So this is a plus 2x squared. And the same thing here. You have a negative 10 and a positive 2. You're subtracting and getting a negative 8x. Now in this next one, we're going to do a similar way. 5y to the second minus 2y plus 8. But we know it's subtraction now because of this negative sign. And the rule we've mentioned before, when you have a parenthesis and there's a negative sign in front, just remove the parenthesis and change all the signs. So this positive 6y becomes a negative 6y squared. This becomes a positive 2y, and this becomes a negative 3. So now when you add them, here this is going to be a negative y squared. Here these cancel out completely, and you end up with a positive 5. So again, the strategy strongly recommended. Write out your items. 6x to the third minus 3x squared plus 3x minus 6. And then you're going to change each of these signs and put them under the correct like term column. So this is going to be a negative 8x cubed. This is going to be a positive 9x squared. Now there is no x, so we skip that one, and here we're going to put a negative 6. So making it much easier, lining up your like terms. And here it's going to be a negative 2x to the third. Here this is a plus 6x squared. These just come down, plus 3x, and this is a negative 12. Okay, now for this one, again, depending how you want to set it up. So here, this is a plus sign in front of these. So we have a 6k. Now this is going to be a working innermost parenthesis first. Let's write that. That'll be k minus 5 here plus 4k. So k plus k is 5k. Let me straighten that. That's better. So I've done it this way. K and this 4k add up to 5k and my negative 5. So now the negative signs outside of the bracket, I could have used parentheses. So now I change both signs. This becomes a negative 5k and this becomes a positive 5. So we're left with a k plus 5. Now, they may be slightly different ways to do it, and I didn't have to line them up. There weren't that many terms, so I just did it horizontally. And you're welcome to do these horizontally as well. So we'll give you time to set this one up too, and I will set it up. So the opposite of a negative makes this a positive, and negative, changing the sign here makes that negative. So we now have 8k minus, and then combining my terms here, I have a negative 2k plus 6. So this is 8k. Now this will become a positive 2k. And this one, changing its sign, is a negative 6. So we end up with 10k minus 6. And that looks good. Again, the answers are on page 51. Now we move, and I may or may not have mentioned this, that when you have one term like this, this is often referred to as a monomial. And when you have three terms, this is a trinomial. But right now, since we're multiplying, this is just considered one whole term. And this would be like a factor, and these are terms within this parenthesis. And we're going to use the distributive property, that we're going to multiply that negative 4x by each one of these, and we're going to get three answers. So we'll give you a chance. So this is going to be a negative 4x to the third. We just add our exponents here. This will be a negative 28 x squared. And now this will be a positive 3 times 4 is 12x. Now a little later in this unit, we're going to be taking this trinomial here and taking out the greatest common factor to reverse from this product and factor it. So this way it's sort of easy. The other way is a little more creative and challenging. All right, let's do this one. So this will be 12x to the fifth minus 18x to the fourth plus 15x to the third. We're just multiplying that monomial by each of the terms that are within the parenthesis. And this is what we get. And then later, we're going to look at this trinomial and factor out the greatest common factor from each term. Now, for example 3, we are multiplying a binomial, that is two terms, by a binomial. And there's a couple of ways to do it. Eventually, we're going to use, of course, the FOIL. But I did want to show you the other ways. We take the first term of our first binomial, which is y, and multiply it by this, 3y plus 7. We then take the second term of our first binomial, which is plus 5, and multiply it by 3y plus 7. And then we will actually do that here. So we get 3y squared. This is going to be plus 7y. And this is plus 15y. And this is plus 21. Now notice in the middle, we usually have two like terms. So we summarize that then by saying 3y squared plus 22y plus 21. Now as we look at this, we need to check our work. Yeah, 5 times 7 is 35. I'm not sure where I got the 21 from. Anyway, check your work. And now this is the trinomial that came about from multiplying this binomial and this binomial. Later in this unit, we're going to take this trinomial and try to get it back to the factors of it. This is going to be a really important skill that we'll be working on. Now, I said this was one way to do it. Let's look at the FOIL now, and I'll write it up here. Y plus 5 and 3y plus 7. Now, FOIL is an acronym that stands for the first, which are these in each of your binomials. The O stands for the outers, which are these. The I for the inners, which are these. And the L is for the last, which are these. So in a sense, we're repeating this pattern, but in a little different procedure. And this is going to be critical to be able to undo this. So let's do the first now. Y times 3y is 3y squared. I do my outers, and I get my plus 7y. I do my inners, and I get plus 15y. And I do my last, and I get 35. Yes. Notice I still have like terms, and this will become, when I collect my like terms, they come out the same. So this is a method often used, sort of the horizontal method. Now, one more way of doing this, and that would be y plus 5, and then you can put 3y plus 7 underneath it, and here we're going to multiply. So 7 times 5 is 35. 7 times y is 7y. Now we go to the next row. 3y times 5 is 15y, putting them in like term columns. And then 3y times y is 3y squared. Now you add them up and get 3y squared plus 22y plus 35. So all three ways work. And the one you want to normally use when you're multiplying a binomial by a binomial is this one. So let's use the FOIL for this one here. First will be 10x squared. My outers, a negative 25xy. My inners, a negative 12xy, and my last, a positive 30y squared. Now notice your middle terms are like terms, so your answer then, as a trinomial, is 10x squared. Group these together, a negative 37xy plus 30y squared. And I see we're getting a little long here on this tape. So outers, I should say first, 2x squared. Outers now a negative xy. Inners a positive 6xy. Last a negative 3y squared. Group our like terms, and we end up with this. So again, the key is we're going to see these trinomials later, and we'll want to know the technique of factoring them. And we are, in a sense, undoing the FOIL. So the use of the FOIL for these is where you want to go. All right, we'll wind this up.